All right. Hello, everyone. Welcome back. Welcome to another ASP.NET Community Stand-Up, where we discuss the latest updates to .NET web development. I'm Daniel Roth. I'm the Principal Product Manager for ASP.NET Core and Blazor on the .NET team. And today we've got two very special guests joining us on the stand-up. First, we have Noah Falk, Principal Software Engineer on the .NET Diagnostics team. Yeah, go ahead and say hello, Noah.
Hi, how's it going?
Noah, it's great to have you on the show. And then our second special guest is Grégoire Verdier. Grégoire is a senior software engineer working on large-scale performance problems at Criteo. Welcome, Grégoire.
Thank you. Hi.
It's great to have you on the show. Quick announcement before we get started on today's topic, which is about building a better PerfView with Blazor. If you haven't already heard, this week is Visual Studio Live at Microsoft HQ. Be sure to check it out and watch the live streams that are happening on the Visual Studio YouTube channel all this week. It should be great. Lots of new updates on the Visual Studio tooling and also great talks about building software with .NET and AI and all the latest, greatest technologies. I'll be there, and I hope you'll be able to tune in too. Okay, so today what we're going to be talking about is Grégoire's investigations and efforts and open source contributions, which I guess culminated in building a really awesome new tool for the .NET community, which is this .NET Event Viewer, which is like a PerfView replacement built using Blazor, using our modern web framework for .NET. So Grégoire, tell us a little bit about yourself. Like, what do you do? Like, what's your professional work in the .NET space, and what got you started with .NET?
Yeah. So I'm a software engineer. I'm mostly working in .NET. I studied in this company called Criteo maybe 6 or 7 years ago. I was mainly working on the platform code, like SDKs. Such as how to connect to databases, how to connect services together. And Criteo has an absolutely huge scale. Like last time we checked, last time I checked, it's like 20 million requests per second. And so
wow,
we have a lot of performance and scalability problems. And that's where I started doing more and more performance. And then I joined the .NET performance team at Criteo. And that's what I do all day.
Is Criteo primarily a .NET shop, or its backends implemented using .NET? Or is it
Yes.
does it have a sort of mix of technologies?
So I think we have 40,000 servers now. And like probably half, well, maybe more than half is .NET. The rest is basically the offline job that is written in Scala, I believe, stuff like this.
Some Java and Scala-based technology.
Like Hadoop stuff.
And Criteo, what kinds of requests are these? Like, what type of industry does Criteo operate in?
So we do web advertisements. So basically, you go on the website. We receive a request that asks, do you want to display advertisement for this person? And we have to answer in a few minutes again, yes, and how much are we willing to pay to buy an inventory and display our advertisement.
So the ad space, so timely, low latency responses, I assume, are highly critical in that.
Yeah.
In that space. Makes sense. And when you joined Criteo, were you already familiar with .NET? Did you have a .NET experience prior to coming to Criteo, or is that where you got your first exposure? Like, how did you start writing your first .NET and C# code?
I studied in university. I was doing some special program where we were writing .NET code actually for the university and for some external clients sometimes. And that's how I started. But honestly, I didn't know much before joining Criteo because we were doing way easier stuff than what we do at Criteo. And that's really at Criteo where I started to really understand everything about .NET. Well, not everything, but way more things.
There's a lot to understand about. I'm still learning about .NET. I've been working on .NET now for over 2 decades. I think I came straight out of college when I started working on .NET at Microsoft back in like .NET Framework. I think 2.0 was in the works when I joined.
Yeah.
Even after working on .NET for all those years, I still learn all sorts of stuff about .NET.
Yeah, so I got pretty lucky because I started working with .NET around the release of .NET Core, so I didn't have to. Well, at first I didn't have to deal with the .NET Framework stuff, which is pretty nice.
Got to jump in right in with the modern .NET stack.
Yeah,
that is nice. Okay, and you've also been heavily involved with like .NET open source. Like I know you've been active on the .NET repos and contributing improvements.
Mm-hmm.
Tell us about that. Like what got you involved with the .NET open source community?
So in my daily job, I have to fix performance issues, and they either come from our code. We write like code that is not super performant, so you have to fix it. It almost never comes from the .NET runtime. Usually it works perfectly. The SDK is great.
That's right. But no smiling.
Many times it comes from external libraries. Like for example, to give you an example, 3 years ago, we started replacing Memcache with Aerospike. It's a NoSQL database, and we found some performance issues in the Aerospike.NET clients, and these issues became like critical for migration. So I had to jump in and do a few bit patches on the clients. But same thing with like Kafka, Cassandra, all the .NET clients we use. Usually we have so many requests that we hit all the performance issues that exist. And
you provide a nice stress test for many of the open source libraries in the .NET ecosystem.
Yeah, exactly.
Okay, and so then you're contributing back then fixes to those libraries, or just I guess reporting the issues at least to them to.
Usually it's just faster than to just do the pull request myself. That's usually what I do.
Wow, awesome. Was that intimidating when we first started doing that? Like when you were thinking about submitting your first pull request to one of these projects, were you nervous about it, or how welcoming did it feel?
I think at first you're wondering, does it make sense what I'm doing? Like, am I fixing it the right way? But then you become more and more confident. Like, I think I'm very confident in my .NET skills now, so I think I'm okay with it.
I think it helps now also that we have all these AI tools available to sort of sanity check a bunch of the things that we're doing, to be like, okay, I think this is right. Hey, Copilot, what do you think? Does this look reasonable? Yes. Okay. Well, then that's a good sign. Hopefully, that means I'm on the right, at least on the right track, or reasonable first cut of the approach. Cool. Okay. So those are primarily then like ecosystem libraries in the broader .NET ecosystem, like libraries for various services and products. But I think you've also been involved directly in like the .NET org, right? Like, haven't you also been looking at like the .NET runtime repo and looking at the issues there? Tell us about that. Like, how did that happen?
So sometimes I have some performance issues or stuff like that, and I'm thinking, if we could have like this API in the .NET SDK, that would be great. Most of the time, I'm too focused on one single problem, and they tell me, no, that's a little too focused as an API. Maybe you just want to implement that yourself. But also, sometimes I'm missing diagnostic tools. And one big journey that I had in the .NET runtime is having better diagnostic tools for ThreadPool starvation. Because Criteo, it's a business that started in 2005, and in 2005 you didn't have async programming. I don't know, maybe it was a concept in the software engineering world, but that was not a thing in .NET. I think the task class, it was released in .NET Framework 4,
Oh, this
And
is
the async.
when did we introduce async await, Noah? Do you remember? It's been so long now.
I mean, I'm not sure I could give you an exact year, but if I was guessing, I don't know, maybe in the vicinity of like 2012.
Yeah,
actually, a couple of years, something like that.
I think I checked earlier, and .NET Framework 4, I think it's 2010, and async await 2012.
Well, so we had Noah. Not bad.
We had 2 years. Before you had 2 years of complete hell, where you need to do callback hell. I don't know how people deal with that.
Begin end pattern was I mean, there was async in .NET. It was just it was an older, less less convenient pattern for
the old begin end methods, that little pattern.
Well, I never had to deal with that, and I'm very happy about it.
So ThreadPool starvation is kind of an interesting topic. Like, I think people who've dealt with performance and working at scale probably have heard of that, but maybe some folks on the stream are not familiar with how this occurs. It'd probably be good to just talk a little briefly about what is ThreadPool starvation and how does it occur, and how is it related to the asynchronous programming models that we now have in .NET.
So maybe it's time to pull up my screen.
Let me do that. I'll add you right here. There you go.
Here we go. So this is the 20 million requests per second I was mentioning earlier. And so it's a big scale. We have a lot of problems. But anyway, for the ThreadPool starvation, as you know, when you do asynchronous programming, you use tasks to return a future, a result that will complete some time. And everything works great as long as you use async awaits. But there's a little property on the task class that gave me a lot of work. It's this guy, the little results. So usually you would await task when you want to wait to get the results, but you can also just do .result, and you'll have the exact same result. And it's right there. It's right there in the class. So why not use it, right?
So convenient.
It's so convenient. And every time I'm working with a junior developer, they're like, it's right there. Why shouldn't I use it right there?
And you're in some synchronous method, and you're like, oh, if I await this, then I have to change my method signature.
Yeah,
like I just do .result, then I don't change it in my code. Yeah. It's so easy.
And since our code is like we have some like super old code, like the business started in 2005. So at first everything was synchronous, and then we started adding asynchronous APIs, for example, to access our databases. But some code only had a synchronous path. So you want to call this async method, but you're in a synchronous path. Well, I'm just going to do .result, and it works, and that's it. But what will happen is that you're going to block the thread, and it will greatly impact the throughput of your thread pool. Maybe Noah, you can help me here to explain exactly why sync over async is bad. So sync over async being coding .results or stuff like this on a task.
Sure. I can take a stab at it at least. I mean, it's basically your thread pool has a certain number of threads in it, and every time you queue up some work item to do work, which most of these task APIs do in some way, they say, run this later, and usually that means something's running on the thread pool. And then you call any API that blocks. So result is one of those APIs. Wait is another one, but it could be anything. You could just call, monitor.lock on something that doesn't finish quickly. And so then you've blocked that thread. And if your thread pool has many threads and you block one of them, that may not be a big deal. There's still, some other ones around that can do work for you. But often what happens is you wind up blocking all of them or many of them. And now when the thread pool needs to do some new work item, all of its threads are busy. They're all blocked. They're not actually accomplishing anything useful. They're just sitting there waiting for something. But there's no new threads available to take work. And the thread pool does have some heuristics in it to add more threads if it detects that sort of all of the existing threads are busy. But it won't add threads too quickly to avoid a different performance problem where sort of spikes of load can just explode the number of threads, and that has different bad problems. So anyway, the number of threads will only grow kind of slowly. And if you are adding work into the pool very quickly and you're doing lots of blocking, then the rate that the new threads are coming in will not be nearly fast enough to handle the rate at which you are attempting to do work. And so, generally all advice is like, try not to block on the thread pool because it's a limited resource, and you use up one thread every time you block until you finish blocking.
And the way you avoid blocking on the thread pool is this whole pattern of doing sync. We call it sync over async, right? Like where you try to do some synchronous work over what is fundamentally an asynchronous action.
Yeah, I mean, that's one of the common ways that you wind up blocking on the thread pool. But like there are others, but that's a common one.
Yeah, so calling .result on your async task, that basically says wait for the task to complete using this thread, and that blocks the thread. Calling .wait, all those patterns that when you're in an async context and you try to turn it into a synchronous like operation, you're probably blocking the thread there. So don't do that. Particularly in aspnetcore, like aspnetcore did a lot of work to make things asynchronous all the way down through the pipeline, but it also made it very susceptible to this thread pool starvation problem if people are used to trying to do sync over async style things. So one of our big guidance points for aspnetcore is avoid that at all costs. Keep things flowing. Use a wait. A wait will do the right thing. Avoid sync over async patterns. And so there's actually a good doc in the .NET docs about thread pool starvation. I'll include a link to that in the URL list for this stand-up, so people can look at that.
And so this is the problem we had when we were like migrating to async, and the performance impact can be a complete disaster. Like it can completely obliterate your performance. Like your CPU won't go over 20%, so you're like losing, like the cost of your service is like exploding. And so I was debugging many of these issues, and I was starting to think, I think we're missing something in the .NET runtime. So this investigation are way easier. And I think it's in 2020, I opened a very, very naive issue on the .NET runtime, asking like, maybe we could have a metric that says, oh, here you did a task.wait or a task.result. And it would like increase like a metric. And so on my boards, I could see, oh yeah, I can see a latency issue, and I can correlate it. With this new metric. But I think the .NET maintainers, Noah included, they were like, I understand the problem, but this is not the right solution. So at the end, we closed the issue, but I was still struggling with this issue. So 2 years later,
Can I jump in before we move off from that? One thing I love about what you did, though, is that you opened the issue, you had a proposal, and you opened it up then for discussion. Like, and sometimes it can be tempting to be like, oh, I've got this great idea. I'm just going to go ahead and start writing code and do a pull request. And then you run the risk of like doing a bunch of development work without the design and the framework considerations, the ecosystem considerations being discussed. And then people sometimes we end up having to close PRs like that, and you've lost a bunch of your time, and no one likes that. So I love that you started out with the design discussion. Noah, it looks like you were involved in that earlier chat.
Your issue was great. I mean, like it was very well presented as far as I was concerned. It was easy to follow along. We had a nice little discussion there. It's the role of a maintainer to get people from where they are initially. Sometimes issues start off super vague. Hey, I'm having this kind of problem. So, maybe they have an idea of what would solve it. Maybe they have no idea whatsoever. Sometimes you have to, give a lot of questions to sort of, dig into it, figure out the right details, figure out what's important. I mean, that's all just part of the job of being a maintainer, is to basically, work with people and, get to the heart of the issue and figure out what, might solve it. And it's totally if you sort of had all of the background ecosystem knowledge, then, maybe you should be a maintainer and I can, retire and go do something else. That's just not even the expectation that the issue posters will show up with that knowledge.
I think it's worth speaking a little bit also to that, this notion of this is a good concept that fixes this problem, but not necessarily something we want in the platform, like in the framework itself. And Noah, do you want to just speak briefly about how you think about those types of decisions? Like why not this one? This was fixing Gregoire's problem and Criteo's problem. Is that not important? Don't we want to make the platform better? Why would we not do a change like this?
Well, I think if I'm remembering correctly, I think for this one, I think I had a couple of comments that I put there. So a couple of things was I did suggest, I was like, hey, maybe there's some things that we already have that might either address your problem or that you could use to address your problem. I think number 1 and number 2 in my list were basically of that flavor. It was hey, before we start adding new stuff, let's at least check out what we already have, because no reason to add something new if the problem is already solved with what's there. And then number 3 there, I think that was me sort of saying, let's think this through and figure out if we even did this, would it wind up being that meaningful for you? Would it move the needle that far on the problem that you needed to solve? And I was speculating, I'm actually not so sure that it would. I think, but some of that's also just me kind of exploring the problem. Maybe it's, I don't understand it well enough yet. And, you're going to write back and be like, oh, you're crazy. This is why, it helps so much and you're way off. And that's totally cool too.
So there's a discussion about the actual the fit of the feature to the problem that it's trying to solve. Mm-hmm. There's a base level of sort of conservatism that comes with maintaining a platform also. We try to add the minimal thing that will meet the broadest usage, because we're obviously there's only so many.
Right.
We have a pretty large team on the .NET team, but we have limited resources at some point, and so we don't want to add stuff willy-nilly. We want to just add the features that we want to support in the long term. And then also, once we add something and it's in the platform, because we're a platform, there's no takebacks usually. Usually means once it's in, then we have to keep supporting it and maintaining it, because someone in our ecosystem of 5 million some odd .NET developers that use the stack every month may have taken a dependency on the way that feature currently works. So we try to make sure we only add the right things, which makes things.
There's a lot of kind of, as you say, there's a lot of sort of cost benefit analysis, and certainly a desire whenever possible to find the most minimal solutions to the problems that we can, or find the things that are, I don't know, maximally applicable to everybody, as opposed to the thing that maybe only handles a narrower situation.
Yeah. So challenging set of constraints, but still. Worthy effort, right, Gregoire? What happened next? What was the next step in this journey?
One thing that I want to point out is that earlier you mentioned you were asking, do you just do the report or do you also do the PR? And here I had absolutely no intention to do the PR. I was just throwing an idea, but I don't think I would be ready to make a change to the .NET runtime, at least at this time in 2021.
And I would say that's still a valuable contribution. You bringing your insights from working at Criteo at scale, huge production deployment with your unique set of problems, and sharing your feedback, your ideas, your suggestions as GitHub issues. Is super
we
valuable.
Learn a lot as maintainers just by interacting with people through these issues. We certainly don't start off knowing it all, and I don't claim to know it all now either, but I know more than I used to because people tell me things through through these interactions.
Sometimes I worry that our community members maybe are there's probably a bunch of community members who have never opened a GitHub issue in our repos, and I think that's a missed opportunity both for them to share, get their feedback addressed, and also for us to help understand the community's problems.
There's this like incredible breadth of people out there that use .NET for all sorts of different things, and I strongly suspect there's a huge portion of them that we never hear from, we never interact with. We have to make our best guess as to what it is that they do with .NET.
And so after this issue was closed, I continue my journey at Criteo to like investigate this kind of ThreadPool starvation issues. And it's like 2 years later, I created another issue where I think I had a better idea I had a better understanding of the problem, and I think I had a better idea about how we could fix it. So instead of having a metric, in the .NET runtime, there is a very cool feature. There is a server running in your runtime, and you can send commands and ask to like collect events. For example, you can collect GC events to understand the GC behavior. And here we're thinking, wouldn't it be super useful if we had an event whenever a thread is blocked? And that's how the conversation started. Do you remember this one, Noah?
Yeah. Well, not like all the details, but I remember having it.
And so I don't remember if someone asked me, hey, do you want to try to do a PR? But I think...
Yeah, I think I did.
I think, here we go. Were you interested? And I was not super confident about it at this time, but I'm like, okay, I'll give it a try. And so that's where I opened this new PR in December 2023. And I think it took some time to get merged. It was merged in... Oh, sorry, that's not the right one. The PR is...
Should be linked at the top of the...
at the top.
No,
or maybe
it's got
the
Karmer.
Wait, I think I've seen it right there. Here.
Drafted.
Here we go. And that's the PR. Okay, November 14, and I think it took a few weeks to get merged. Like, at first I didn't know what I was doing, because it's not, most of the work is not in .NET. You have to get really into the runtime, and it's C++ code.
Mm-hmm.
So I was not super familiar with it, but Couvel.
Count is his first name. It's one of our engineers.
Yeah, and it was great. That was a super good experience. And at the end, we were able to get something that made sense, that worked on also all the possible runtimes, because you have to make it work for normal .NET, but also Mono.
Yeah.
And
maybe native AOT as well. I don't know.
Oh, yeah. There's that too. Yeah. And it took some work. At the end, we were able to merge it.
Woo!
Nice.
Got it in. That's very impressive.
And so the first thing we did after it was merged is cherry pick these commits in our internal fork at Criteo. Because we have our internal fork, because we've used it, for example, when they migrated from .NET Framework to .NET Core on Linux. On Linux, there was a few performance issues and we had to contribute, like do some quick performance issues to unblock the .NET migration. To unblock the migration.
So you did a whole fork of the .NET runtime, and Criteo was running on a forked build of .NET?
Yeah, I think we're still running on the fork, and we are starting to migrate to .NET 10. And I think for the first time, we won't have our own fork, because all our patches have been merged in .NET runtime. So we'll run on a clean .NET, which is exciting.
Wow. it makes me wonder how many of our other customers run on a fork. I imagine running on a fork to be kind of a challenging operation, but
it's very challenging.
It's always a little, it's a pain because you have to build it yourself. It's a little annoying, but it was definitely worth it. But also, we run .NET at a super high scale, and we have one team dedicated to .NET in our company. So I guess we have the enough human power to do this.
Mm-hmm.
But I guess in smaller companies, they cannot do this.
Right. If I had to guess, I would guess that it's rare.
Yeah.
I don't feel like I hear about it very often. So.
Yeah, I can think of one other case. It was specifically for the WebAssembly runtime that I know of, where they were running on a separate branch, but then they got onto the main trunk recently as well. But yeah, I assume that's fairly unusual. If you are doing that, we would love to hear why, and let's get those fixes that you have in your fork up into the main branch so that everyone can take advantage of them. Yeah, that's interesting journey.
And so once we had these events in our .NET, we also added the integration of this event in PerfView, because we were using PerfView a lot to investigate our performance issues. And that was completely game changer. Like, we found so many ThreadPool starvation all over the place in so many applications. Also, we found sync over async. Like, it was super easy. I'll show later how it looks like to investigate a ThreadPool starvation. But so we found sync over async, but also we found other issues. Like, for example, we were using parallel.forEach, and we noticed that it can also cause a ThreadPool starvation, because when all the workers are done and the current thread still has some work, it's going to synchronously block the current thread. Right, Noah? I'm not saying.
I'm not super familiar with I mean, I know conceptually what it does, but the implementation details of parallel for each I've never looked into. So I'll just take your word on it.
Sounds like you're not alone. Like I see someone in the chat, Alex, also was asking about something similar, about building API to avoid using parallel for each without creating too many threads. Sounds like maybe potentially related as well.
I mean, I think that really probably depends on the context of your problem. I mean, to some degree, parallel for each, like, its job is to, parallelize your work across a bunch of threads. So sometimes you might say, well, that is exactly what I want to do. I guess the biggest question that you have to decide when you're using an API like that is you have to decide, well, how many threads do I want to devote to this parallel processing out of some, total number that are reasonably available to me? And sometime you might decide, you're like, oh, I don't have very many available. Maybe I shouldn't parallelize at all, or I should only parallelize a little bit. And other times you might say, oh, I have a lot of threads and I just have one work item here that needs to get done. I really want to use all my threads, to make this one work item go as quickly as possible. So usually, I guess what I hear from folks that operate at larger scale, usually they don't have a problem. They usually have many, many work items that they would like to get done. And so they don't put more than one thread on each one because they have plenty to run in parallel already. But if you only have a single work item and you want it done as quickly as possible and you have a lot of threads, parallel for each could be exactly what you want.
Yeah, that was actually our use case. It's like, we have this request, we want it to be done as quick as possible. Even like taking priority over other requests, but we want it to be super fast. And so, but that had the issue where that could block the current thread. But in .NET 6, we had parallel.forEach async that saved us here. But we found other issues, like, for example, parallel for each and parallel for each async. They have to acquire a lock to enumerate the IEnumerable you provided. So that was another issue where it was not sync over async, but it would still cause a potential thread pool starvation.
Interesting.
And so that was great. We were in a state where debugging thread pool starvation became really easy. But only our team, the .NET performance team, was doing it. And I was trying to understand why owners of their own service were not super familiar in doing this. I was trying to push them like, look, it's not that hard. And one thing that I found is it's because it was because of PerfView. I think I have a screenshot of PerfView. So PerfView is this Windows tool that allows you,
beautiful design. Like
it does. I think it does many things, but we would use it to open our net trace that you can collect with .NET Trace. And it's hard to use. It's not super user friendly. Like usually I would know just a few use cases for PerfView, like you click here, you click here, you click here, and you have what you want. But like most of the buttons, I have most of the inputs, I have no idea what they're doing. And so that was the first issue. Like people were like, it looks too hard, I don't want to use it. The second issue is that it's a Windows only tool. And currently I'm working on a Mac, and actually many other coworkers are working on Mac OS and Linux. And so they just couldn't use this tool at all. So they had a thread pool starvation issue, and I was like, oh yeah, you should use PerfView. And they're like, I can't. I'm like, oh well, I guess I'll do it for you, because I was using Windows at the time.
PerfView as a service, like is what that
yeah, and that's sad. And so that was the second issue. And the third issue is, even though they were on Windows, I had to tell them, oh, you have to install that tool. And when I said install a tool, I could see that I was almost losing them. They're like, I need to install something. Like, yeah, maybe next week I'll think about it. And so like, again, I'll do it. And these are the three issues that made me think maybe it should be more simple. We should have something that is cross-platform, that is more user-friendly than PerfView, and ideally that doesn't even require a download. Like maybe that works in your browser. And when I was thinking about something like this, at the same time, I was hearing a lot about Blazor, that allows you to run .NET in WebAssembly, so directly in your browser. And I thought, that could be a great use case for my problem. And that's where I started developing a tool that I called .NET Event Viewer. I was not very inspired that day. You can view .NET, yeah. And so that's the name. And maybe I can do a little demo of that tool.
Please do. I think the name sounds great. I mean, it sounds like a very Microsoft .NET style name. It yeah,
absolutely.
And resonates with me.
And that's the tool. So it's not more beautiful than PerfView. I didn't make a lot of effort on that, but I believe it's easier to use. So
it was very clear to me what I needed to do.
Yeah.
You sent me the link at one point, and I was just like, oh, what's this? And then I looked, I was like, okay, very self-explanatory.
Cool. That's nice to hear. Nice. I didn't get a lot of feedbacks for now, but yeah. So the first thing you need to do is drop your net trace file. So again, to collect events from the runtime, you use .NET trace. I made some example here, and the new cool kid in the events is the wait handle events. It's the new events that I introduced in .NET. And I followed the debug. There is a documentation that now features .NET Events Viewer. It's this documentation, the debug ThreadPool starvation. And if you scroll down a little, it mentions .NET Events Viewer. So I followed this.
Due to your PR on the docs.
What's that?
Due to your PR.
Yeah.
Just so people know, not only can you submit PRs to the product, you can submit PRs to the docs, and you did.
Yes. And I was like, why not add this tool in this doc? And it was welcomed well, I think, by you, Noah.
Grégoire, can you do a favor and scroll up to the top and show where the little edit button is? That's so people who want to be able to do this. If you do that ... next to the focus mode, right next to the button, right there should be a edit button. See that edit button? If you click on that on any of the .NET docs on Microsoft Learn, it will take you right to the doc in the repo, and then here you can click the edit thing again to actually start.
And there you go. There's you're the most recent editor of this doc.
Yeah.
Anyone can do. I do this all the time. Like if I find a little typo or something that's not quite right, and like the Blazor docs, edit, submit a PR. It's really easy. So if you're looking to get your to cut your teeth on your first open source contributions, this is a really easy way to do it.
And so in this documentation, there is a sample application that seems to have a ThreadPool starvation, and so we can debug it using .NET Trace plus this tool, .NET Events Viewer. So you have to collect the wait events using the .NET Trace collects and the CRL events wait handle. And I already collected it, so I'm just going to load it. There. Here we go. So we loaded the file. We can find some information about the file here. That's the name of the file. That's the date it was collected. Duration of the trace, some information about CPU, the OS. So you see I'm using Mac, .NET version, and the command line. And the first thing you can do is just run the query. It will list all events in the net trace. And you can click on a single event, and that's what an event looks like. You have some information about the thread the event occurred on, a timestamp, the activities, and a custom payload that depends on the event type, and also a stack trace. So this one doesn't look super interesting. For example, we could add a filter. So we're going to filter on these events because there are other events in the trace. And we can say associated object ID not 0. And so here we'll get more interesting events. Can you remind us what the that word object ID is, Noah?
I believe that was the pointer to the monitor lock object that you blocked on. I think that's what you used it for.
And so but I don't remember what does it mean when it's 0.
Oh, probably that you didn't block on a monitor lock. You blocked on something else that wasn't a monitor lock.
So what could he, that's what I'm confused about that. Like, what does it mean? Like you block on what if it's not a monitor?
Like a manual reset event or so, like there's other synchronization primitives that aren't monitor lock that you could block on.
Okay, got it. And so you get a stack trace. And so this stack trace is interesting. It means that here manual reset event slim.wait was called. And it was called by task.spin_block_wait. That was called by task.internal_wait_core. That was called by task.getResult, which is actually task.result. Yeah. And so it seems like we're doing sync over async here. But is it a problem? Because if it's just a little sync over async once and it never occurs again, well, I guess that's fine. So maybe you can look at another event. It looked kind of the same, but I have many events. So I wish I could aggregate them. And that's what the second page does. It aggregates the events by their stack trace. So it will build a tree of these events. we don't really need that filter. And I'm going to run the query again. And here we're going to see all the stack traces merged together where we had a wait handle wait start event, meaning we blocked the thread, which is usually not something you want to do. Otherwise, it's going to cause a thread pool starvation. And if we go down that tree, so we can see our manual reset event wait again. That was called by this. And so we have 468 events, meaning we blocked the thread 468 times. But one thing that I'm wondering when I see this is like, okay, I blocked it, but if I blocked it for like 1 microsecond, it's fine. And I added a little thing here. You can select the wait duration instead of the number of events. And I'm going to run the query again. And now it looks way worse. So remember my trace was like 7 seconds. And during the 7 seconds, we blocked for 400 seconds, which sounds weird, but it's because we have multiple threads. So each thread can individually block on the same thing.
Right.
And that's where you want to explain that a little better. And I go ahead.
So you've got something like 60 threads blocked for 7 seconds apiece or something like that.
Yes.
Maybe a little more than that.
Yeah. I guess you do a 431 divided by the number of seconds. You should have an idea of the number of threads. But anyway, we probably find our issue here. But let me look at the other ones. Here we got a 30 seconds spent on stuff. Is that a problem? So what we are remember that we're looking for thread pool starvation. So all the dedicated threads that are not in the thread pool are not super interesting to us, because even if they are blocked, they won't impact the throughput of the thread pool. And these two guys here, the timer queue thread and the portable thread pool gate thread, it's something that you probably find in all .NET events, if I'm not mistaken. Noah, could you tell us a little more what those threads are?
You're going to push my thread pool knowledge here.
Mm-hmm.
Well, I'm pretty sure, I believe that gate thread, that the gate it refers to is sort of the gate of letting other threads into the thread pool. So that thread's job is sort of to take a look at the number of work items that are pending and the current number of threads and a few other heuristics like how much CPU load is currently on the machine, and make a decision of, should I let more worker threads go into the pool or should I take some away? So it's kind of like the maintainer of the thread pool. And yeah, so it just sort of sits there monitoring the situation, deciding when to add and remove threads. And then I believe that that timer queue there, I don't know, I might be shooting myself in the foot. I would assume that it probably is multiplexing multiple timer callbacks on a single thread, but I'm actually not so sure about that one.
And so these threads, they are blocking. We can see they're blocking for 14 seconds, probably just because they don't have anything to do. So they just block, right?
Makes sense.
And so we probably found our issue. Let's jump on the code to make sure it makes sense. So it seems like we're calling task.results in this code, like dag scenario controller. It seems like I don't have the code, but I think I'll be able to find it easily.
I think, yeah, that sample app, that's the
browse code. And if
right.
I remember, oh, here we go. So controllers, that's probably this one. And we said the method was task wait. Is there a method task wait here? Yes. And as you can see, we got something that I assume returns a task, and we do sync over async on it with dot results. So here the fix would be to turn this method asynchronous. So you make it return a task of action results, make it async, and then you can do await here, and all your problems will disappear.
Awesome. That looks great. And this tool is built with Blazor. It looked like it's just hosted as a like a static site on GitHub pages. Is
Yes,
that right?
absolutely. So one of the super cool feature about Blazor. So there are two modes. There is one where you have a server that can send you some HTML. I'm not super familiar with this mode because I use the other mode where you don't have a server at all, just to serve the static content. But everything is in WebAssembly, is running in WebAssembly in your browser. And so I was able to host it as a GitHub page because everything is static. And so it's super easy to deploy.
So when you're uploading your trace file, also you're not like sending that off to Gregoire's private server to take a look at. It's actually sitting still locally in your browser. Like it's not actually going server side anywhere.
That's a good feature because a net trace contains very sensitive information. It contains all the static traces of your code, and so you don't want to upload it anywhere. And so here, when I select a file here, it's not going to upload it anywhere. It's just processing it in the browser.
Very nice. And then I assume it's also good for your hosting costs, right? Like the hit on your wallet to host this site is effectively, I assume it's free. Like it's just
I'm using Microsoft infrastructure. Thanks, guys.
And for us, it's very. I mean, you're just hosting a bunch of static files for a standalone Blazor WebAssembly app, which is what this basically is.
Mm-hmm.
So hosting static files is very cheap for us to do.
Yeah.
Do you ever have any issues with performance of processing large trace files? Like I know one of the tricky bits with Blazor WebAssembly is it is a at least by default an interpreter-based runtime. We do have some light ability to do JITting in WebAssembly now. We have this JIT interpreter mode that we introduced, which makes things faster, but it's still not going to be as fast as like a server-based .NET runtime that has full JIT support and running on your like server hardware. Is it ever sluggish as a result, or is it good enough?
At first, the performance were catastrophic. When I was loading a net trace here, it would take like minutes, and I was super confused why. Because when I would run it on my computer, like outside of WebAssembly, it was extremely fast. It was like instantaneous. And so I applied a lot of optimization on my parser for net trace, like a lot of them. I spent so much time on it, and it was still pretty bad. And I found that web, like by default, it will use mono runtime, which is, I think, because it's more portable than the default .NET runtime, but it doesn't have the same performance at all. And what I did is instead of using a JIT and everything, I'm using AOT. So the .NET code is compiled directly to WebAssembly instead of having a runtime in the browser that would JIT the code and JIT code that is not super good.
Awesome. Yeah. So this is using WebAssembly ahead of time compilation to improve the runtime performance. And how much did that help? Like how big of a boost was that?
Like extremely huge. Like maybe I can find it again. I think maybe in the commits I put the numbers, but like maybe it was like 10 times faster, something like this.
Yeah. So the trade-off there obviously is the when you ahead of time compile, you'll get better runtime performance, but it's also at the expense of some larger download size. So like the initial load performance of the app might take a little longer because you have to pull there's more WebAssembly instructions that you need to represent every .NET IL instruction. So it tends to bloat when you use AOT, which I know some people get confused by, because like when you're using like native AOT, you think maybe it's making things smaller, like you're getting Like if you want to target a really small container image, you
close,
can use native AOT and it will shrink. The reason why it shrinks is because of the trimming step, where we remove a bunch of the .NET IL that you're not actually using, and that shrinks down the amount of code that you then need to AOT, which does actually increase the size, but because you trimmed a lot of it away, it's not as bad. With Blazor, we always trim, so that's you don't get a trimming gain by using AOT because you're going to get that anyway. So it tends to get a little bit bigger, but for an app like this, you're not trying to hit probably, the lowest number of milliseconds for the app to load. You're expecting to spend some time in this app.
So for an app like this, it doesn't matter. I think people, it's not for it's only for like developers. I think they're ready to wait like 1 second to load the page. Whereas if it was like for anyone in the world, like people would get maybe a little impatient. But here, so here, if I click the refresh button, I wonder how big is the website. So it's
tiny, small.
Is that
because of caching?
That's 24 megabytes.
That's the oh yeah, so they got the transfer size there. Great, yeah. So it's a little.
And so here we can see all the WebAssembly being loaded. But when you refresh it a second time, it will be like way faster.
Because of the caching logic.
Yeah, here I loaded less than 1 megabyte.
Is the project open source? Like if people want to contribute improvements to this application, where can they find that?
It's there. It's open source. So I was thinking, should I add more features? Because on PerfView, there are way more features than what I'm providing. But also, there's one thing that I've learned when I was working on personal open source projects, is that the bigger your API surface, the larger the maintenance costs, because people will start like opening issues about, oh, this feature is broken, this thing is broken, this feature could be improved. So for now, the website, the tool is very low in features, but it's also
minimalistic.
Yeah, something like that.
Focused. I think we're saying focused on a key scenario.
Focused. And I think it will stay that way for now, because I don't want it to be a burden to maintain.
Makes sense. Yeah, and it's kind of cool to see how you've been contributing to the open source ecosystem as a contributor. Now you're a project maintainer, so you get to dealing it with both sides, and as people open issues and file pull requests and such, getting help from the community and then getting to participate in them that way. I think it's also worth mentioning, and I saw that I think you did a couple of really nice blog posts about your journey building this application, and then also using it to track down threat starvation issues. Yeah, that's great. They're linked right there from the repo.
The second one is probably the most interesting if you want to really understand how to debug a threat pool starvation, because during this presentation I went over it very fast, but usually it's not that easy. And I'm using an issue we got in production, where you can see all the metrics look so weird. Like there are spikes everywhere. Like the number of requests is spiking too. Like it's weird. And I'm going over this in this article.
Fantastic. So definitely worth a read. I was taking a look at those blog posts, and they are very well written and very insightful in terms of how you approach these problems, how you approach building the tool. So highly recommend reading those if folks are interested. Great. Okay. Well, we're getting pretty close to time here, Grégoire. That was fantastic. Thank you for sharing with us your open source journey, the awesome work that you do at Criteo, and your fantastic contribution to the .NET ecosystem with the .NET Event Viewer tool. It's linked to from the .NET docs for people that are looking for that and want to give that a try. It's public on the internet for you to use. So give it a go. And if you have any feedback, go to the GitHub repo and let Grégoire know about how it can be improved. Maybe even offer some of your time and resources to help out with that. Grégoire, thank you so much.
Thanks a lot for inviting me. That was great.
Thank you.
Noah, thank you for being here, answering all the deep technical questions.
Yeah.
And everyone else, thank you for joining us today. We'll be back next week with another ASP.NET Community Stand-Up. Until then, happy coding. Thank you, everyone.
Thank you.
Bye, everybody.
Bye.